Okay. So to backtrack, we're doing the first one, okay?
Alright.
Okay.
Is this being different from yesterday?
We're doing the intercepts. The X-intercept and the Y. See how this graph, we sketched it. Well, we did points. See how this is going to cross the x-axis? What point is that? And then if it continues forever, where does it cross on the y-axis, right? So the y-intercept. So we're going to solve for them algebraically. But way back in basic algebra, when you guys are finding x and y intercepts for a linear equation, it's the same moving forward. Nothing changes. Okay? Okay. So if I want the x-intercept, I'm going to let y equal 0. So in place of f of x, I'm plugging in a 0.
Okay.
So I'll pause, and then at some point I'll stop the video so that you guys can copy,
Number 1, right?
clarify, yes, number 1, and then I'll restart the video again. Okay, I'm recording those.
Do we have to do this Saturday?
No. Okay. Do you guys remember solving by square roots? Okay. So now this is solving by what roots? Cube roots. Yeah, by cubic roots. So notice how that's a 3.
Yeah.
Where's my calculator? Oh. You're not using this square root button. If in the yellow, see how that yellow has a root of 3?
Yeah.
We're going to be using that. So we're going to go shift and hit that button. Oh, you can't see. That's terrible. Solving by cubic roots. Okay, keep going.
Yes.
All right, so first step, you take the k value and you're going to add it, because we're going to inverse it over the equal sign, right? Okay. So if I jump it, it's going to become a positive 6, right? So 6 equal x plus 4 cubed. Now, you don't have an a value here, otherwise you would divide by that a value. So if it was a 2, you divide by 2. But it's a 1, so we leave it alone. We don't have that step. Okay, now once you have this grouping isolated with the cube, now you come in with your cubic root. Because what's the inverse operation of cubing? Cubic rooting. Just like what's the inverse operation to squaring? Square rooting.
Yeah.
Okay, so red marker. I'm going to cubic root it. I'm going to put a 3 there because it's the cube root, because that is a 3. If it was a 4, we would do the 4th root. If it was a 5, you do a 5th root.
So now we're talking about.
Yes. Okay, now your calculator, you need to take this cube root of 6. So you go to your calculator, and I'm going to hit shift, because when you hit shift, see how it's in yellow print?
Yeah.
It activates the yellow above this button. So if I hit, well, I should turn it on. Shift, and then this root, see how I get my little 3 root?
Yes.
See that?
So we'll be using this on number 3?
Yeah, on 2 and 3.
2 and 3. I already did number 3, but you can
No, but we're looking for intercepts. You're trying to find where this crosses here. And then where. No, it's correct.
So I can do it either way.
No, this is like, okay, no, so here's what it is. See how this point came from here?
Yes.
And how this one came from here?
Yes.
Okay, that's kind of like the center of like the vertex. Okay, so you then when like you get away, when you get above and below, you get your white table. So you put together the sound here.
So I did 2 days what we did yesterday.
No. You found it on the XY table.
So I can do it either way?
If you get lucky. You just got coincidental lucky.
So if anything I want to be there,
You need a lot of like statistics.
Yeah, but once you plot your points, like the fact that you see that it's crossing your Y, then you know you found it. You don't need to do it. Just
You like cross it with this. Cross it across this part right here.
so like here, you have to find that one.
Okay. Alright, I think I got that.
Okay. What are we doing? 6? Yeah. Alright, so if I plug in the 6, are you guys here? Okay. So now you get 1.8, correct?
Yes. Yes.
Okay. So we're still on 1. Alright, you get 1.8. And then I get x plus 4 here because inverse operation, cube root and cubing are inverse.
Yes.
Because look what we're finding.
So now you just subtract the 4.
Okay, question though. You guys remember when we were square rooting?
You would divide it.
Oh, they're on the tip of the paper. Okay. Oh, here. Remember how you guys would do plus or minus? Okay, here you're like, hey, Miss Kenny, are you going to do the plus or minus 1.8? Because right now I just have it at 1.8. And it's going to be positive. Now, just think about it. Why wouldn't I put the negative 1.8?
Because when you subtract the 4 right now, right?
No. If you guys kind of let it sit and roll around, you would come up with it.
Wait, you said why would you put a negative?
Right, okay.
Why? You said why would you put a negative?
Yeah, so like, when I take, so what I'm saying is, see how I took the cube root of 6?
Yeah.
And my calculator gives me 1.8. Why didn't I go plus minus 1.8? Why did I leave off the negative option?
Because it's not a plus.
No, because remember when we solved by square roots with quadratics, we did plus or minus. Because what's positive 2 times positive 2? 4. What's negative 2 times negative 2? What's negative 2 times negative 2? Positive 4. But because I'm cubing, what Kayla kind of said, because I'm cubing, what's negative 2 times negative 2 times negative 2?
Yeah, because yeah.
I would get negative 8.
You get a negative answer.
Right, so let me write what I'm saying.
I get what you're saying.
You guys, so smart. Like I said, it's intuitive. If you were given more time, you would kind of come up with it. Okay, look. The reason why the square root of 4 is plus or minus 2 is because positive 2 times positive 2 is positive 4, which is 2. If I gave you negative 2 times negative 2, it would still give you 4, which is 2, right? So that's why the square root of 4 is plus or minus 2, because you still get the 4. Okay. However, if you guys are cube rooting, negative 1 times negative 1 times negative 1 is the equivalent, right? Cube rooting. Right? This would give me negative 1. Right?
Yeah.
But if I gave you positive 1, positive 1, positive 1, this would be a positive 1, right?
Yeah.
So, with cube roots, if the original number inside the radicand, if it's positive, then when you cube root it, that number is going to be positive. If it started off negative, then it'll be negative. So if we're referring to 6, if I had 6 and 6 is positive, right? Because -6, we took it over +6.
Yes.
And I want you to cube root it, whatever this number is, and they're telling me 1.8, it has to be positive because this number's positive.
Yes.
Had it been negative,
It would be negative.
a -6, then you know these would have been,
That makes so much sense. I get it.
right? So,
Can you look at this? I can't.
yeah, hold on, just wait for that. So the reason why when we cube root, you don't just always go plus minus now. You have to pay attention to the original number. If it's positive, then when you get your 1.8, it is only that positive 1.8. Had this 6 been negative, then you would have got the negative 1.8. So here, it's a positive 6, so my cube root is a positive 1.8.
Okay.
I know when we solve this math, there's all these little embedded details. They kind of take a while. You guys have to get comfortable with it. But every year, students have to get comfortable with the cube root. And why did you use the positive? Why didn't you use the negative? Okay, so now what do you do?
Okay.
Right, take that 4. And now it's -4 plus 1.8 equals x. And I get 2.2. And so this is my X-Intercept. This is where it crosses. Right, beautiful. And so if but if I slide Desmos, that doesn't record it, but oh well. So when I slide Desmos over, that cubic function that you graph, ladies, that cubic function that you graph, it should be crossing, which I'll show you guys on Desmos, but at that point I'll stop the video. It's crossing at that point.
Okay.
So you square rooted it to find some y value?
No, we're finding the X-intercept.
Oh, okay.
We'll do the y. We haven't even gotten to the y.
Oh, okay.
Remember, the first time we ever do something together, it takes forever, and then as you get comfortable with it, it's like a quarter of the time that it takes me.
Isn't there no y-intercept though?
We'll see.
Alright.
We'll plug in 0. Throw it in. It's just, I think, a really big number. Usually with cubic functions, some of the numbers take off really fast. Because you cube it.
And would I still do the...
Yes, you gotta go times whatever that number is, like 5 times 5 times 5, and that's why the numbers get really big.
I remember these being more.
But if we're finding the y-intercept, would you have to FOIL it?
No, because the x goes away because you substitute for 0.
So it would be 4 cubed?
Yes. And then that 6 at the end.
I got them from the crop store.
Ladies, math. No talk.
Oh.
Well, you can move on with the y-intercepts. You have the algebra skills to do the y.
That doesn't mean it's wait.
Okay, so let me stop this.